So we're doing period. So we're going to back up, make sure there's a few definitions we've got to have. After that, we do sine functions. And what we're going to do with the sine functions is we're going to take the unit circle, and instead of it being in a circular fashion, we're going to lay it out over an XY axis so it will actually kind of move up and down so you can see what it is going to be. But anyway, so here we go. Here's the main things we've got to get first. When we're talking about periods and sine functions, the first thing is we're going to talk about what a periodic function is. And for all intents and purposes, what we're looking at for this part of it, basically it's just a function that repeats the y values. Because if you repeat x values, it's not a function. It's something else. So periodic function, again, for every x we've got, as we go through this one, that basically we're going to have a certain set range of y values that we're going to go over for this thing. All right, we're going to talk about a cycle, not a bicycle or a motorcycle or a tricycle. So cycle, that is one complete pattern and for what we've been thinking about with all the trig, if we talk about a cycle, basically this is one trip around the unit circle. So a cycle, it's one complete pattern where you've done all the x and y, or you've done all the y values that you can do, and then so that again, that's kind of what we're thinking about in this case. It's one trip that's around the unit circle. All right, when we talk about a period, that is the horizontal length. And again, if we think about what we're doing at this point, that is, because again, we're still kind of tying back to the unit circle, that's going to be your circumference. So again, this is where we're kind of bridging the gap. We're going from unit circle back to an XY coordinate plane kind of thing. So we're kind of, bridging the two parts and pieces of it. All right, amplitude. That's your vertical length. Most of the time when I talk about the amplitude, they may talk about it being from 0. They may also talk about it being from the midline, depending on the problem and depending on how far you stretch this thing out. We haven't talked about midline yet. And then the last thing that they may talk about is the midline. Now, for what we're going to do, because again, we're not going to get too awfully complicated on this one. For right now, we'll just scratch out midline. I mean, we can kind of do 0 or midline because we're not going to move the graph, so we'll have to worry about anything different on that one. We're going to have our midline for this one always kind of be at 0, so you can kind of tie those two things together. Now, when you go on into pre-cal, that's where they're going to take this and stretch it out a little bit more, where they're going to add a few little things and do some more stuff that we didn't do just because of where we are time-wise. So we're just making sure we've got the basics covered, and then we'll come back again in pre-cal and they'll dig into this a little bit more. So amplitude is your vertical length from 0 or from the midline, and midline is your horizontal line that is halfway between the max and min. Now, when we talk about the max and min, in this case, we're talking about the max and min y values. And again, for what we're doing with our midline, we're not going to move our midline. Our midline is always going to be at 0. So basically, it's going to be just to make things a little bit easier, because later on, again, when you get pre-cal, they're going to take these same graphs for sine and cosine that we have, and they're going to have it so you go up or down a little bit, and your midline will move, but your amplitude would still be the same. So you've got to kind of, we're talking about either from the zero or from the midline. So and again, that will change just a little bit as we go through though. In the pre-cal, they'll come back and dig into it a little bit more as long as we've got it here. Okay, so here is our sine function. So that's making sure we understand what all the basic stuff in a periodic function or periods. Here's where we actually talk about the sine function. All right, and it's y equals a times the sine of b theta. So when you see that, when you see that O with a squiggle through it there, that's theta. That's part of the, I guess, the Greek alphabet. We do alphas and omegas, and do betas and thetas, and basically it's just a different angle, different number if you want to kind of think about it here. If you want to think about it this way, here's another way you kind of think about it. Put it in terms that we use. Theta is like x, so y is equal to a times the sine of bx. So if you want to think about theta being x, then you can kind of interchange those two things there.
Wait, is it the sine of bx, or is it the sine of b times x?
It is. It's b. Yeah, the sine of, and then b times x. If you want to think about it that way. Yeah. So the sine will be the sine of whatever this number that you get here. So some people don't like the theta part. Just realize that theta is just another variable. So theta is the same thing as x, because we're used to seeing x a lot. So just think about that as being x there. Okay, so when we're talking about the a and the b in this case, a and b are just numbers. They're coefficients. Now, they might be real numbers. They might be rational numbers. They might be irrational numbers. Most of the time, they're going to be just regular integers of some kind or another. They may mix it up where a and b might be something else. But most of the time, a and b are going to be integers. They might make them something else, but most of the time, we're dealing with integers. All right, now, where those numbers dig into this thing, here's what we do. If you take the absolute value of a, that is your amplitude. All right, and if they give you the number that's b that's here in front of x, b is your number of cycles. Okay, and now the b by itself doesn't really do a whole lot, but the b will kind of help you get to this part of it, because they're going to ask you to find the period, and the period is 2 pi divided by b. So a is your amplitude, and then b is your period, or b is your cycles, which then helps you find your period, which is 2 pi over b. Okay, now here's where you get to draw a little bit of a graph here. Okay, we'll do a basic graph of y equals a sine bx, or y equals a sine b theta, whichever one it is it's going to be. Basically, just draw an xy axis, but stretch out the right-hand side, really far here. The top and the bottom, that's a or negative 8. So that's going to tell you how far up or how far down you're going to go. Okay. Now, and if you think about the unit circle, where does the sine, when we start here at 0, what is sine at 0? It's 0, right? So when we start graphing this thing, we're going to start at 0. And you may be saying, well, how in the world are we going to graph 1/2 and square root of 2 over 2 and square root of 3 over 2? We're not. We're not going to worry about that. We're going to worry about just the points that's easy, because this would be 1 that's at the top here. So if you notice your sine values, we go from 1/2, which is 0.5. This is like 0.7. This is, I think, 0.8, something like that. When you get here, it's 1. And then the numbers start to go back down, right? Now we're back to 0.8, back to 0.7, back to 0.5, and then back to 0. So if we graph the numbers for sine, they get bigger till they get to the top. And then once they get to the top, it starts to fall back down. So if we graph this thing, here's what we're going to look like. We're going to go up and up and up and up till we get to the top of the graph. And then once we get to the top, we're coming back to the middle. So that part looks exactly like that part. And then on the bottom, now the numbers get negative. So we get negative till it bottoms out at -1. And then it's going to come back and move back until it gets back to 0. So then the bottom part of this thing is we're going to come up it this way, bottom out, and make it back to there. So it's taking the unit circle, but breaking it apart into pieces. So it's not just a circle. Now we're actually moving, up and down as we go through this thing. And if we wanted to keep going, and again, this is where we're just going to stop basically on one cycle, one trip around. That if we wanted to keep going, and again, this is where pre-cal will come in and stretch this out a little bit farther. They're going to have this thing keep going, and then keep going, and keep going, and then they'll start talking about more stuff. But we're just going to stop with one cycle, because if we can get one cycle, then everything else we kind of pick up on it. All right, now here's the hardest part that you're going to have to figure out, because you've got this top, the middle, the bottom, and then this piece that's here. You're going to have to figure out what those 4 values are going to be. And sometimes it will be easy, and sometimes it won't be. So it just depends on the problem. Okay, now the one that's going to be easy to kind of get, the period that's here, this 2 pi over b, that's your last number that's right there. Okay, so we're going to start at 0. We're going to move up and down, basically make like a unit circle, but top half and bottom half. Again, this thing will finish up at 2 pi over b. And then in just a minute, when we get some actual numbers, we'll show you how to find these other numbers that's here, because that's the other important numbers we have to find. All right, everybody ready to jump into it, actually do some actual numbers here? Okay, so let's give you some actual numbers so you can see, what it is and what it looks like and all the other pieces of it here. All right, let's go with y equals 4 sine x. All right, and again, if we're talking about just the basic layout of it, that's our basic formula here. So our a value is 4, our b value would be 1. Okay, and that's going to get us through so we can figure out what everything is going to be to find all the parts and pieces of it. So for amplitude, we're just going to put amp just for short. It's the absolute value of 4, which is 4. And again, the b value by itself doesn't really tell us, it does, but the main thing is we need that for the period. And the period is 2 pi over b, which is 2 pi over 1, which is just 2 pi. Okay, in most every question, they should ask you for probably those 2 things. They'll ask you for the amplitude, and they're going to ask you for the period. They might occasionally ask you for the midline. The easy thing is right now, if they ask you for the midline, it's 0, because we're not moving these graphs up and down either. It should always stay at 0. Top of the graph is 4. Bottom of the graph is -4. Okay. And as far as we're graphing these, everything should go pretty easy because all we're going to do is start at 0. The next point here is going to get us to the top, back to the middle, to the bottom, and then back to the middle. All right. And again, the one thing that we know is whatever the period is, that's going to be that last number that goes there. Okay, and the big thing you've got to do is that once you've kind of got the basic layout of the graph, because the graph shape should be the same every single time, because that's what sine's always going to do. It's going to start at 0, move it up, back to the middle, underneath, and then back around for this thing. That you've got to find these 3 values, and sometimes they're easy, sometimes they're kind of hard. In this case, we're going to do this to get the first number. Divide the period by 4.
Is it always 4? Or
Yes.
Is it just 4?
Always 4, because because basically if you think about when we did our movement around the graph, we had like the 4 ordered pairs that were easy to find were 1 0, 0 1, -1 0, and 0 -1. So it's basically those 4. It's the XY axis and 1 unit out from the origin to each part of those. So basically we're always going to split it into 4s for this thing. Okay, so for this problem, it is 2 pi divided by 4. All right, now here, and the way we're going to make this thing really easy is that it should work out for these problems that this will simplify and this will make this 1 pi over 2. Now, and normally we leave the 1 pi, we take the 1 and kind of chunk it. For this one, leave the 1 in there for just a second. Now, we'll go ahead and put it here because this is pi over 2. But if the first one is 1 pi over 2, this is our first number here. If the first one is 1 pi over 2, it'd be okay that the second one would be 2 pi over 2? Which, again, the 2's would cancel, right? Just make that pi. And then your third number would be 3 pi over 2. So there should always be that you're going to have a 1, 2, 3 order when you go through this one to kind of get what you're going to do. Now, somebody may be saying, well, that's the same numbers from unit circle because we had pi over 2, 2 pi over 2, which was just pi, and then 3 pi over 2. Now, it's not going to be that way every single time. We're just using this one to make sure that we get some easy numbers here. And we'll actually change that here in just a second. But it should always work out. Now, again, I'm picking the numbers out so that every time you go through this one, after you do this 2 pi divided by 4 to get the first number, it should be 1 pi over something. And then the next one would then be 2 pi over something, and then 3 pi over something. And then so that way there's always a pattern as you go through these. If in pre-cal, if you did this, let's say the first number had been like 7 pi over 16 or something like that, something where it wasn't, the first number was 1, you would just have to double that number, make it 14 pi over 16. And then for the third number, you would triple it and make it 21 pi over 16. So basically you multiply by 2 and then you multiply by 3. Okay, but for hours, it should always be easy. It should just be 1, 2, 3, and then you simplify those numbers if you can. Okay, so there you go. There's your final graph with all the numbers kind of filled in between. All right, let's do a couple more. Make sure we got it. Make sure everybody's okay with it. And then if we'll let this kind of sit for tonight. Again, we got Tuesday off. We'll come back in on Wednesday. We'll actually talk about cosine because cosine is very similar to sine, setup wise, and how everything goes here. All right, so for example 2. Let's do this. Let's make it so it's y equals sine of 4x.
Didn't that just be the same formula?
Well,
Oh,
no, yeah, because A and B values are going to change. So now our A is 1 and our B is 4. All right, so we're doing the amplitude is the absolute value of 1, which is just 1. And for the period, that is 2 pi over B, which is 2 pi over 4, which is pi over 2. Okay, so amplitude, that's again how high up and below the graph we're going to go. And again, for what we're doing, our amplitude's always going to have 0 in the middle. When you dig into this stuff a little bit more in pre-cal, it may not always be at 0, so your midline would change the value of where it's going to be. Sometimes you have to find the midline. For us, the midline is going to be easy. It's always going to be at 0, just because of the way we're picking our numbers. All right, and again, we can go ahead and go 1, 2, 3, and 4. And again, this was pi over 2, so this thing is going to stop at pi over 2. Okay, so again, we're going up to the top at the first mark, back to the middle, to the bottom, and back to the middle. All right, and again, we've got to get this first mark. So for the first number, that is pi over 2 divided by 4. It's many like, oh, it's that complex fraction thing again. It is, but here's a good thing about this one is, if it's pi over 2 over 4, there's a little bit of a shortcut. If you've got like a fraction divided by another fraction here, the shortcut for that one is you can just multiply these two numbers together. So any of these that you happen to wind up doing, if you wind up with pi over something over 4, because we're going to divide it by 4, the shortcut is just multiply your denominators together. So just pi over 8. Now again, technically, it's 1 pi over 8. Up here, we're just going to put the pi over 8 because we need it there. But again, the second number is 2 pi over 8. But we can simplify, right? Make it pi over 4. And then your third number is going to be 3 pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8. Technically, this would be 4 pi over 8. But again, we can simplify a couple of numbers along the way to make this work out just a little bit better. Okay. And again, for us, where we're going to pick the numbers out, it's going to work out. It's going to be 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. It's just some of them are going to simplify as you go through these to get the numbers to get there. About right there. So far, so good. All right, let's get at least a couple more in. Show you a couple little tweaks and turns we got to go through. All right, everybody good there? Everybody still copying? Pause for a second. Okay. All right, this time instead of using X, let's use theta, just to throw you off a little bit. Again, still not a big deal because it still works out the same way. Okay, so our A is 1/2, our B is 2, and with the A, again, the A is for the amplitude. It's the absolute value of 1/2, which is just 1/2. And so maybe saying, well, do we need to worry about the absolute value? Yeah, we'll do one more here. The next one we'll do actually make it so that you've got to do the absolute value here. Our B is 2. And again, for the period, we need that one because it's 2 pi divided by B, which is 2 pi divided by 2, which works out nicely because it's just pi for the period. Okay. Now, the hard part that's going to be in the homework when you're doing these, because these are going to be multiple choice, is that they're not going to mark these values like we did where we did, put pi over 8, pi over 4, 3 pi over 8, pi over 2. It's one of those where they're going to give you just different numbers set up for like these parts, and you've got to figure out what those numbers are, because it may be that this thing may go from like 0 to 1, or maybe this is going from 0 to 2, and it's going to stop somewhere in between. So the hard part the easy part for us is figuring this part out. The hard part is going to be matching up these numbers on the graph on Math Excel to make it all work out. So that's going to be the tough part, because Math Excel, it'd be great if they would give you numbers like this and be real easy, but they're not. They're going to give you just some random numbers that you've got to then figure out, okay, what numbers did they use and how far up and down is this thing going to figure everything out here. Okay, so starting at 0, again, up to the top, back to the middle, to the bottom, and then back to the middle. And we know that last number that's here is pi, so we're good there. All right, now the good news on this one is, what happens when you take pi and divide it by 4? Yeah, pi over 4, right? You don't have to do anything. It's like, oh, okay, well, that's easy. That's pi over 4. Again, technically, that's 1 pi over 4. The next one would be 2 pi over 4. The next one would be 3 pi over 4. And technically, that would be 4 pi over 4. But again, if you've got 2 pi over 4, you can make that pi over 2. 3 pi over 4, you cannot simplify that one, so it will stay there. And again, technically, 4 pi over 4 would cancel out and leaves with just a pi. Okay, so the numbers should just go 1, 2, 3, 4, but some of the numbers through here you're going to have to simplify just based on what the number values happen to be.